Hello friends, in this video we are going to see a profit matrix or a maximization problem, and the problem goes like this. There are 4 workers and there are 4 jobs. When a company gives a particular job to a particular worker, then the company makes the profit as shown in this matrix. So they will say either the company makes profit, or they may say that if a particular job is given to a particular person, the company saves the amount given in the matrix. So both mean that they are profit matrix, and always as a good manager you like to give that job to that particular person where he saves more money or he gets more profit, or the company gets more profit. Hence you would always like to maximize the profit, and hence this is known as a maximization problem. Now the algorithm that has been given to you is a algorithm that has been worked out for both minimization and maximization problem to make it more easy. So let's follow the algorithm. What does the first step in the algorithm say? The first step in the algorithm says check whether the problem is balanced or not. So the problem is balanced because it is a 4 by 4 matrix. So problem is balanced. Your step number 1 is done. Step number 2 says if problem is unbalanced, make the same balance. So I did not do step number 2 because the problem is 4 by 4, it is already balanced. Third step says if problem is maximization, then multiply the profit matrix by -1 and convert it to minimization problem. So the moment I convert it to minimization problem, the further steps of the algorithm will be as it is. So I'm going to go to step number 3. It is a maximization problem, so I'm going to convert it to a minimization problem. What am I going to do? I'm going to multiply the whole matrix by -1. So when I multiply the whole matrix by -1, I will get -8, -5, -9, -8. Here B, I will get 6, -6, -7, -4 and -10. C, -5, -6, -10 and -6, -4, -5, -12 and -10. I have done the step number 3. What does step number 4 tell us? Step number 4 tells us do the row operation. Do the row operation. What is row operation? Take the minimum of each row and minus it from the elements of the same row. So when I do the row operation, what do I get, friends? I get A, B, C and D. What is the minimum here? The minimum here is not -5, it is -9. So you have to be very, very careful here, friends, that though the number is large, but when you see the magnitude, it is -9. -9 is lesser than -5. So this you have to be very careful. So what will happen now? You are going to minus it. So how you are going to minus it? We'll see here the first one. Okay, I have indicated -9. So it will be -8 minus of -9. This is equal to -8 plus 9. This is equal to 1. So I am going to write here 1. So this is the example for what? It is for this element. Okay, it is for this element. Now I have got 1 here. So -5 minus of -9 is 4. -9 minus of -9. So -9 plus 9 is 0. Here it is 1. So don't go wrong when you do the row operation. Always everything that we get here should be positive numbers. If it is negative number, that means you have gone wrong somewhere. So what is the minimum of B? It is not minus 4. It is minus 10. So you have to be very careful here. It is minus 10. So how do I do this? Minus 6 minus of minus 10. So minus 6 plus 10 is equal to 4. So I will get here 4. I get here 3, 6 and 0. Similarly, C I will get the minimum is 10 here. So I will get 5, I get 4, 0 and 4. And here the minimum is minus 12. So I will get here 8 minus 5 minus of minus 12. So minus 5 plus 12 I will get 7. I will get 0 here and I will get 2 here. So I have completed my row operation. Friends, let us do the column operation. What does the column operation say? Minus the minimum of each column for the elements of the same column. Now let us do the column operation on top here. Okay. So here one thing you have to be very careful is that you have to worry about the signs. Okay. So remember here minus 10 is lesser than minus 8. So you have to be little careful when you're calculating here, and all your problems will be resolved. So don't go wrong here. So we'll do the column operation. Okay. So I do the column operation here. I will keep this matrix, original matrix as it is. So I do the column operation A, B, C and D. I take minimum of the column. What is the minimum of this column now? It is 1. Minimum of this column, it is 3. Minimum of this is 0 and 0. So I take minimum of the column and minus it from the elements of the same column. So I will get 1 minus 1 is 0. 4 minus 1 is 3. 5 minus 1 is 4 and 8 minus 1 is 7. Here minimum is 3, so I will get 1, I get 0, I get 1 and I get 6 here. Here it is minimum is 0, so doesn't make any difference. Array 0, 6, 0, 0. Here the minimum is 0, so 1 minus 0 is 1, 0 minus 0 is 0, 4 minus 0 is 4 and 2 minus 0 is 2. So I have completed the column operation. So what is the number of the column operation? That is number 6. Now I have done the row operation and I have done the column operation. That is step number 5 has been completed. Okay. Now what I do? I go to step number 6. What does step number 6 tell me? Step number 6 tells me that select the row or column which is having minimum number of zeros. Make an allocation there and draw a line horizontally or vertically to cancel maximum number of zeros. Friends, as I told you, always go from top to bottom. Once everything is over here, then go from left to right. So let's go from top to bottom. Let's take the first row. If I take the first row, what am I going to get? I have got 2 zeros in the first row. So I have got 2 zeros in the first row. In the second row, I have got 2 zeros. Leave it. In the third row, I have got 1 0. I have got minimum number of 0. I will make an allocation here. Draw a line to cancel maximum number of zeros. I should not draw a line horizontally because I do not cancel any 0. I have to draw a vertical line cancelling maximum number of zeros. Friends, you must be wondering why we want to cancel number of zeros, because we are going to allocate whether it is 0. So if I draw a line like this, there are all probability that you will again allocate A to this. That means job number 3 is done by A and C. So we should not have a duplication of allocation, and hence we try to cancel maximum number of zeros. So I have done this. I found out row number C having 1 0 allocated here, drew a line vertically to cancel maximum number of zeros. Again, let me go back to the first row. First row, I have got 1 0. Fantastic. I will allocate here. Draw a line to cancel maximum number of zeros. I can draw line either like this, or I can draw line either like this. Preferably try to draw a line where you are not going to intersect. Okay, preferably. So you may say one step. So you will do allocation number 1, allocation number 2. Again go to row 1. Row 1, no zeros. Row 2, B row is 2 zeros. C row is no zeros, D row is no zero. So I'll come to the column. Column 1 is gone. Column 2 I have got 1 0. I come across it first. Allocate here. Draw a line to cancel maximum number of zeros. So I'm going to draw a line here because I'm going to cancel this 0. Now I'll see column 3 and column 4. No zeros are remaining. All zeros are over. Now I will see how many number of lines are drawn. How many number of lines are drawn? 3 lines are drawn. Okay, so lines is equal to 3. Order of matrix is 4 by 4. Hence solution is not optimum. I should go to next step. So what is the next step? What does next step tell you? Next step tells you take the minimum of the uncovered element. So friends, what is the minimum of the uncovered element here? If you see the minimum of the uncovered element, it is 1, 1, 1, 4, 6 and 2. These are the elements that are uncovered. Okay, this 0 and this 0 element that are covered. This 4 and 7 are elements that are covered by the line. Don't touch those elements. So go with the steps. We'll go with the minimum of the uncovered element. The minimum is 1. Any one, they want to see only the value. So the value of the uncovered element is 1. I have selected 1. So what am I going to do with this 1? Okay, what I'm going to do with this 1? What I'll do is I will add it to the intersections, subtract it from uncovered elements, and other elements which are covered, I leave it as it is. So very simple. So other elements that are covered by the line, I leave it as it is. So I write as it is. I have to minus this minimum from the uncovered element. So this is uncovered element. So 1 minus 1 becomes 0. This is covered. So I write it as it is. This is uncovered. So it is 1 minus 1 is 0. This is an intersection. Yeah. So what will happen to the intersection? Intersection, I have to add it. So it will become 4. It is 3 plus 1. Elements covered by the line, leave it as it is. Here also I have to add it. So it will become 7. How? 6 plus 1, because it is a intersection, and this 0 will remain as it is. 4 and 7 will remain as it is because they are covered by the line. 1 minus 1 is 0. 6 minus 1 is 5. This 0, 0 are covered by the line, so write it as it is. 4 and 2 are uncovered elements, so I have to minus 1, so it becomes 3 and it becomes 2. So I have done this operation. Fine. What do I do next? I start allocating. Start allocation. Row number 1, 4 zeros. It is not minimum. Row B, 2 zeros, not a minimum. Row C, 2 zeros, not a minimum. Row D, 1 0, the minimum number of zeros. Fantastic. I got 1 0. I will allocate here. Draw a line horizontally or vertically to cancel maximum number of zeros. No use of drawing a line horizontally. I'll draw it vertically and call it allocation 1. Friends, I was going row wise. Let's still go row wise. Okay. So A row is having 3 zeros. B is having 2. C is having 1. Here I get 1 0. Allocate here. Draw a line to cancel maximum number of zeros. How will you draw the line? You will draw the line vertically to cancel these 2 zeros. I get allocation number 2. Let me again go to the row. First row 2 zeros. Second row 1 0. Fantastic. I will allocate here. Draw a line to cancel maximum number of zeros. How will I draw the line? I will draw the line vertically. I will call it allocation number 3. Again I go to the row. A row 1 0. Fantastic. I do not see further. I allocate here. Draw a line to cancel maximum number of zeros. Either I draw vertical or I draw vertical or horizontal. Does not make a difference. It is not cancelling any number. Best way is do it vertical. 1 2 3 and allocation number 4. Do I have any other zeros remaining? I don't have any other zeros remaining. So let us see how many lines I have drawn. So lines drawn is equal to 1 2 3 4. 4. Order of matrix is equal to 4. Therefore solution is optimum. And what is the optimum solution? How do I allocate. Friends, in the examinations, do not write only so much and leave. You have to write the whole solution. So don't make a mistake of writing it midway or leave it half. So your solution would be like this. Your solution would be A will do job number 1. A will do job 1. How much profit the company is making? It is making 8 rupees. It is making 8 rupees. B will do job number 4. Second one. B will do job number 4. How much profit is making? 10 rupees. C will do job number 2. How much profit is making? C will do 2. C will do 2. I'm sorry. C is going to be number 2. Here it is going to be 6 rupees profit. And D is going to do which job? It is going to do job number 3. D is going to do job number 3, that is 12 rupees. It is 12 rupees. What is the total profit? Total profit here is 10 plus 8, 18, 19, 20, 18, 20, 30 rupees 36. So if you do this allocation, the company will save maximum money, or it will get maximum profit of rupees 36. So this was a problem which was a profit matrix problem or a maximization problem, but a balanced problem. So if this is unbalanced, what we can do, we'll see in the next video. Thank you very much.